Familiar, NOAA is the National Oceanic and Atmospheric Administration. It's a federal agency dedicated to understanding and predicting changes in climate, weather, oceans, and coasts. Today, we're introducing you to Nic Arcos, who will be talking to you about tsunamis. But before we start, we'd like to recognize that we're all coming to you from the traditional lands of Native communities who have substantial traditional knowledge to share with us. We acknowledge that Nic today is presenting from the lands of the Arapaho, Cheyenne, and Ute Nations in Colorado. And Nic, go ahead and take it away.
As was mentioned, we're located here in Boulder, Colorado. It's a nice introduction on who NOAA is and what we did that was provided by Sarah. And so I work for the National Centers for Environmental Information at NOAA. So you can see our building here, that long building in front of the mountains there. And we're also co-located with the World Data Service for Geophysics, my group that is. So what is geophysics? Just if you aren't familiar with that term, just simply put, it's the study of the Earth through indirect methods. So like using radar or seismic wave measurements. So that's what we mean by geophysics. So our group is the natural hazards group here. And one of our main functions is working with tsunami data. So we work with tsunami data. That means we collect it and we provide access to it. We quality control it. So that's a lot of what we do. So that's what we're going to talk about here, but it's also global tsunami data. So although NOAA is a US organization, because we're part of the World Data Service for Geophysics, we look at tsunami data from all over the globe. And tsunamis, as you probably may know already, don't just affect one area or one country. They affect many countries and can go throughout the globe. So just to get going here, so what kind of data do we look at for tsunami data? So this is actually me on the left on this image here talking to an eyewitness from a tsunami and collecting information from him. So basically tells us what happens, then we record the heights based on what he tells us and what evidence we find, and we basically take all these notes and look at the tide data at the time and figure out how big and how far that tsunami went. So we look at eyewitness interviews after events. We also look at scientific catalogs. Those are some of the big things we look at for historical tsunami data. And I'll take a little step back here. And historical data, what we mean is, in this case, human history. What has been written down or observed by instruments. So the further you go back in time, the less written records we might have or instrumentation we might have. So it was a really nice point that Sarah made about in the indigenous lands that we're on, because there's a lot of places that did not have a written language up until somewhat recently, in the last hundreds or even thousands of years in some cases. So we're really limited with our historical data, but it's still important to have that captured. But for our indigenous legends and stories that are passed down, we do use that information for our data to help verify what areas might have been hit by a tsunami that we know occurred. So it is very important information that we get from our indigenous traditions. So not just moving past the eyewitness interviews and scientific catalogs, we also have coastal tide gauges. So you see a picture towards the left, you might see a pole with a box, and then it's hooked up to these things measuring the water in the water there. So those coastal tide gauges measure the sea level, but they also can measure tsunami waves. Other types of data we have are from ocean bottom pressure recorders. So we have an instrument that sits at the bottom of the deep ocean, and it detects a tsunami wave as it passes over it. And that instrument at the bottom of the ocean sends that signal to a buoy, which you see a picture of here, and that buoy transmits that data through satellites to our tsunami warning centers. So that's how we get that kind of data as well. So that's the kind of data we have here as well. So all this kind of data is used for understanding our tsunami risk in different areas. And we also have things called tsunami models, which help us understand how a tsunami might behave. So that's all this data goes into those things. Now we also have people here that in our group that develop digital elevation models. So you see a picture of that here. So basically a digital elevation model is mapping of the Earth's bare surface above and below the ocean surface. So that's what you see here, gives us an idea of what our Earth looks like. And we use this to help determine how a tsunami wave might behave along or near the coastline. So this ultimately helps us determine which areas might be at risk in a tsunami. So when we're planning, let's say for a city is planning on where to put schools or hospitals or things of that nature, they'll look at a map and say, okay, this is where we expect a tsunami might impact. Let's move those critical infrastructure outside of the tsunami hazard zone. Also, tsunami warning centers use this to help define their forecasting of where a tsunami might impact. So talking about tsunamis, what is a tsunami? Now, tsunami, the word itself, is Japanese for harbor wave. And you can see here from this image, there's a good reason for that. Tsunamis are most easily visible near the coastline and are typically amplified in an enclosed harbor. So once a tsunami gets, if you look at a harbor and you go in a harbor, you'll see that it typically has a really narrow opening to protect the boats that sit in that harbor from ocean waves, right? And from storms and things like that. So when a tsunami wave goes into a harbor, it tends to bounce around in there for a long time and creates a lot of destruction, and a next tsunami wave comes in and so on. So you have these big tsunami waves that are so powerful they can carry boats on shore, like the one you see in this image in Japan from the 2011 tsunami that occurred in Japan. So there's no connection to the tides. So the tidal wave is a term that a lot of people used to call tsunamis, and that's not the case at all. Tsunamis are not caused by gravitational forces of the sun or the moon. So in this case, in the 2011 tsunami event, this wave, the biggest wave, actually not in this particular location, but in Japan locally, was almost 130 feet tall. That's the size of a 12-story building. So you can imagine how big a tsunami can be in some of these areas, a 12-story building. So again, tsunami comes from the Japanese word for harbor wave, but it's not just local harbors. So this is an image here that just popped up, probably on the right side of your screen, of Crescent City, California. Now, this is about 4,500 miles away from where the earthquake that generated the Japan tsunami in 2011 was. And still, it impacted the harbor in Crescent City, California. And it took about 10 hours to get over 4,000 miles. And that wave height in this location was about 8 feet. And again, once the tsunami got into this harbor, it kind of bounced around and created a lot of destruction. So a lot of the harbor was destroyed, as you can see, and boats sunk. So it's not just locally that a tsunami can have an impact, but it's in the distance as well. So we've mentioned in the previous slide that earthquakes can generate a tsunami. So when an earthquake occurs, basically you have two blocks sliding past each other that can cause movement, right? So in this image, you see a great kind of an example of what a great earthquake might look like in a cartoon version. So when those two plates move past each other, an entire column of water is suddenly moved vertically, as you can see in this image, and it's moved vertically so that water is pushed upwards, and that generates a tsunami. Now, a tsunami is not one wave, and that's one of the most important things we have to understand about tsunamis. It's a series of waves, and it's never going to be 3 waves or 7 waves or 12 waves. Every tsunami can be quite different. So we don't know how many waves will be generated but in a case of a tsunami generation. And the first wave may not be the largest. Sometimes it is, especially with landslide generated tsunamis, but sometimes it's not. So tsunamis are a series of traveling waves, and they're really distinct because of their really long wavelengths. They're really long waves, and how long each of those waves are. So we'll talk about that in the next slides. So I give you a few hints here, but what else maybe in the chat you can put in what else generates a tsunami other than an earthquake, and what do you think is which is the most common thing that generates a tsunami? We've mentioned earthquakes. What do you think is the most common, and what might be some other things that generate a tsunami? And maybe Sarah can help me out with any answers that might come in. So if you can go in your chat.
They're saying underwater volcanic eruptions.
Okay, anything else?
That's a good guess. Anybody else out there? I heard Nick say something else. Landslides. They are guessing earthquake is the most common, maybe. Hurricanes. They're wondering if hurricanes cause tsunamis. So we have underwater volcanoes, landslides, earthquakes, hurricanes.
Okay, that's good. And so I'll address some of those, and those are really good. So thanks everyone. And I think someone said the most common was earthquakes, and you are correct. Earthquakes are the most common. So underwater volcanic eruptions, I think that was one of the ones that was answers that was given. That's also correct. And there was a big one that occurred earlier this year in January near the islands of Tonga that generated a tsunami that was observed in all the major ocean basins. And that was a really big one. Landslides was mentioned as well. And hurricanes was mentioned. Actually, hurricanes don't generate our traditional tsunamis in the sense that they were a vertical displacement of water occurred. However, they do generate something that we call meteotsunamis. That's where a storm is moving really fast at the speed of a tsunami wave, and it's putting pressure on the sea surface, and it essentially generates a tsunami-like wave. So that's a really good response as well. So we see those during hurricanes, typhoons, where they tend to be quite small, but they can be destructive, and they'll ride along with the hurricane storm surge. So that's a good one as well. So earthquakes are the most common. As you can see here, over 80% are generated by earthquakes. And we have these landslides that can be submarine landslides, so something that occurs under the water, as well as subaerial, so something that like a rock fall or a landslide that occurs above the water and falls into the water. And then we have volcanoes that can be an eruption, but it can also be a collapse of the caldera, so like part of the volcano collapses and generates, which is almost like a landslide as well. And the pyroclastic flows, actually there was one last week in Stromboli in Italy that generated a very small tsunami where a pyroclastic flow basically just from the volcano went into the ocean and generated a small tsunami. So those are really good. And again, earthquakes being the most common. So now I wanted to talk about where do these occur? The most common ones are earthquakes, as well as some volcanoes. The Ring of Fire you may have heard of, so that red line around the Pacific there that you see in your image is what we call the Ring of Fire. It's a ring of volcanoes around the Pacific Ocean, and they result from subduction of oceanic plates beneath lighter continental plates. So I'll play this image, this animation here, and hopefully it works. And it gives you an idea of what happens here. So the plate that subducts underneath the other plate stores strain for hundreds of years. Then an earthquake occurs and releases all that energy very quickly, within minutes, into the water. The energy in a tsunami wave is fairly spread out fairly evenly, as you can see, throughout the entire water column. So a regular wind wave, when you go to the ocean and see surfers or boogie boarders or things like that, they're riding wind waves, and all that energy for wind waves is right near the surface. But tsunami waves, it's throughout the whole water column, from the surface to the bottom. So you have a lot of energy that's been stored up traveling through those waves. Now that subduction process that we talk about, and you see here, occurs in the Ring of Fire, as well as other areas, but primarily in the Ring of Fire is the most common. And this is why the Ring of Fire is the most seismically active and volcanically active, really, area in the world. So when these tsunami waves are generated, they reach enormous dimensions, really, really big. We talked about the one in Japan, but they can travel across entire ocean basins with very little loss of energy, unlike wind waves. So tsunami waves themselves. Let's talk. Hopefully you can see some of the details on this image, but it might be a little small, so I apologize, and I'll try to cover most of it. So we talked about wind waves. Now, wind waves, when you go to the beach and you see surfers, et cetera, and the waves coming in, from the wave period, which is the period of time from one wave to the next wave, is about 5 to 20 seconds when you're at the ocean on a regular day. Now, tsunami waves is quite different. It's about 10 to 60 minutes can occur between waves. That's how much time, how long that wave is for a tsunami wave. They proceed as ordinary gravity waves, but they're just a lot longer. Now, as you can see in this image, hopefully, their speed depends on the depth of water for tsunami waves. So the deeper the water, the faster the wave is going to move. So if you're in the deep ocean, the tsunami wave is going to go about 500-600 miles an hour, as fast as a jet airplane. So, but it's going to be very small. So if you're in a fishing boat or some big boat in the middle of the ocean, deep ocean, and a tsunami wave passes underneath you, chances are you're not going to notice. It's going to be very, very small, a few centimeters in height. Even a really big one in the deep ocean would be only a few centimeters in height. And because they're really long. So wind wave might only be the length of, let's say, a football field about the wave itself. A little bit more, a little bit less. But a tsunami wave, it can be about 60 miles or more in length. So that's a really long wave, especially compared to those wind waves. So as the tsunami wave approaches the shoreline, the coastline, it slows down because you have all this energy traveling and you just have less depth. So that energy has less space to work in, and it starts to pile up. So what do you think would happen? As the front of the wave, it's so long, as I mentioned, like 60 miles, 100 miles long, a tsunami wave, and the front of the wave is approaching the coastline, and it starts to slow down. So what do you think is going to happen? The back of that wave is still moving fast because it's so long, and you're going to have it shorter and shorter as it approaches the shore, and that energy has to go somewhere, and it goes up. So that few centimeters that was in the deep ocean is turning into many, many feet as it gets closer to land, to shallow areas. So you can have, when it comes on land, a tsunami that can be a wall of water, essentially, because it's going up, of 30 feet or more. And it floods, inundates low-lying areas. So it starts to just flood areas with these really, really big waves. So, but a big tsunami might be over 30 feet. But we've even had tsunamis, as I've mentioned, over 100 feet. But you don't need a huge tsunami hundreds of feet or 30 feet tall to be destructive. Even a 10-foot tsunami or less can be destructive. For example, in 1991, there was a tsunami that occurred off the Caribbean coast of Costa Rica, and it was about 10 feet tall, if that, and it killed 3 people. So you don't need it to be really, really, really big. And the reason is because you have so much energy and that entire column of water, unlike the wind waves where it's just at the surface, moving through those waves. So have a lot of energy going through that. So just to give you an idea of what they might look like. So we have a lot of beautiful parts of our country here in the US, states and territories. And if you ever get a chance to go to American Samoa, it's one of the most beautiful parts of the US, beautiful parts and great people. But unfortunately, they are near a seismically and volcanically active area. And in 2009, there was an earthquake that was felt in American Samoa for about 3 minutes. And within 15 minutes, a tsunami would arrive at the villages there. And the earthquake generated tsunami waves actually that were about 72 feet high for this event. And people did lose their lives in American Samoa, Samoa, and Northern Tonga. So what you see here is tsunami waves on the right carrying a car, flipping it over and carrying it. On the left here, a shipping container. And a shipping container, even empty, weighs about 9,000 pounds. So you can imagine if it happened to be filled. So tsunami waves can move these objects, and they act as projectiles. And they can cause destruction on structures, on, of course, people. And look at all that debris in the water. So as the tsunami comes in and comes out, it's going to take that debris with it. And as it comes back in, it's going to take that debris back in with it as well. So are very, very dangerous because of all the things in the water. And here you just see what's above the water, floating above. You don't even know what's beneath the surface. That can be a lot of other really dangerous things. So a question for you all. How do you know if a tsunami is about to arrive on your coastline? This can be a coastline you may be visiting, or you have family in. I know a lot of you are inland, Colorado, but I know some of you in, sounds like in New York and New Jersey, perhaps California you visit occasionally. So how would you know if a tsunami is about to approach?
You can go ahead and answer Nick's question in chat. So what would you do? Oh, it looks like some people say that the tide might recede or the water might bubble. If you have some, anybody else, earthquake. So if you felt the earthquake, a lot of these people say they're landlocked, so they've not been near the coast, but
Good.
feeling an earthquake's one.
Okay, that's
Anyone
good.
else?
Anyone else? If not, we can. So I think those are good. Those are really, really good. So we talked about earthquakes. So yes, if you feel the earth shaking, that is definitely a sign, and we'll talk a little bit about that. And the tide receding, the water bubbles, that's also really good. So first we'll talk about this. We do have warning systems in place. So NOAA, who I work with, they have 2 tsunami warning centers, one in Hawaii and one in Alaska, and they provide alerts to the US and to other countries in the world. So they send those alerts to emergency management agencies in all the different states and counties and cities that you might live in, and then they provide those alerts to you. So within 5 minutes of an earthquake, usually faster, but 5 minutes is the longest, an earthquake is detected. The tsunami warning centers will know if it generated a tsunami and how big they expect it to be and the areas they might expect it to be impacting. So that's, a really good system that we have in place, but it is based on earthquakes, which generate 80-some% of the tsunamis. But someone had a really nice answer that was correct. There's also natural warning signs. Now, I'd mentioned in American Samoa that for that event, within 15 minutes, they had tsunami waves arrive. So if it takes 5 or so minutes for the tsunami warning centers to get that message out and for you to get that message and act on it, that's quite a bit of time if you only might have 10 or 15 minutes before the wave arrives. So you have to know your natural warning signs as well. So if you feel the ground shaking, that's an earthquake. And if you're near the coastline, you have to know to get away inland or to higher ground immediately. Same thing with hearing the roaring of the ocean. Now, a lot of people we've interviewed that have been near tsunamis or experienced tsunamis, that's what they say. They say it sounds like an airplane or a train, and it's really loud and unusual. We also have the unusual disappearance of water or the bubbling, as was mentioned there. That's another one that we've seen a lot as well. So that's what the natural warning signs are. If you see these sudden disappearance of water, and I don't mean like the changing of the tide that happens over a long period of time. This is very sudden. So you might see fish flopping around or the reef exposed that you wouldn't normally see. So if you're, a lot of people said they are living in landlocked areas, but you might be visiting an area that's near a coastline. So it's things to keep in mind. And here, from 1995, there was a tsunami in Manzanillo, Mexico. You see on a normal day how the beach looks like there on the left. And then suddenly someone took this picture, was actually the sea receded, withdrew very quickly within a matter of seconds or a couple minutes. And everything was exposed, and they could see fish, they said, and rocks that they hadn't seen before. So that's what it might look like when a sea gets withdrawn. So those really good answers there. So what do? You go immediately to higher ground. You never go down to the shoreline to watch a tsunami or to see what's happening. And we've actually had a lot of loss of life because of that. People going out there to take pictures or to collect fish that are suddenly exposed. And it's unfortunate, and that's why we do things like this to talk about tsunamis. And you never go back into an area until an all clear has been issued. And that's by your local police and fire departments, not by warning centers or anything like that. Because after a tsunami, you could have fires, you could have oil spills, chemical spills. It can be a really dangerous area even after the tsunami waves have stopped. So you have to make sure you don't go back in until you're told that it's safe. So has a tsunami ever impacted a coast near where you live or have visited? I'll kind of I've asked this, but feel free to put things in the chat if you have, but I'll talk about my own experience since we have a little, I don't want to take up too much time. So I'm in Boulder, Colorado now, and before this, I actually lived in Hawaii where we worked on a lot of the warning centers there, one of them, and we do a lot of work there. And Hawaii is actually the state of all the U.S. state and territories. Hawaii is the one that has historically observed the most tsunamis. So just to give you an idea, Hawaii here is located kind of underneath, if this was a bullseye, all these circles, in the middle here, and underneath, hopefully you can see my cursor, but in the middle of that and underneath those dots and colors there. And so I took a look in this, showing this map to show you all the different observations that Hawaii has had in their history of tsunamis. Now, all those yellow circles there that you see, yellow and then a few orange triangles, those are tsunamis that were observed in Hawaii but did not cause destruction or damage. While the green and red circles and triangles are tsunami events that have caused deaths or damages in Hawaii. So you can see some are local right there within minutes of the coastlines of Hawaii. And others are farther away. We have some in Alaska and Japan and Tonga, the Southwest Pacific, and then some in Chile, South America as well. So, and if you look at these yellow lines, that's how long it took the tsunami to get there. So see a little one here, hopefully you can see it around the first yellow circle. That's an hour away in tsunami travel time. So if you have something in Alaska that generates a tsunami, it might take 4 to 6 hours to get to Hawaii. So you have a little bit of time to get everybody away from those dangerous areas. And we've had some destructive tsunamis and deadly tsunamis in Hawaii from Alaska. Versus like maybe, let's say, Chile down in the Southeast Pacific. So in South America over here on the right, hopefully you can see my cursor, but if not on the right, it takes about 13 to 15 hours, depending on where in South America it is, to arrive in Hawaii. So you have a lot more time there. So this is helpful for planners to say, okay, if we only have 4 hours from an event in Alaska, what can we do in those 4 hours? How many people can we move? Can we get them all inland? Or maybe they have to go up really sturdy buildings. They have a lot of high sturdy buildings and hotels. Maybe they have to go up. And so what we call vertical evacuation versus inland evacuation. So maybe they have to move up. That's probably what they would have to do in a local event. That's only 15 minutes before the wave arrives, or 30 minutes. And in places like South America, we'd have a lot more time. So we could calmly get everyone to move inland and walk inland to get away from the tsunami waves, the danger of the tsunami waves. So we have a lot of data so that you can actually look this stuff up. And on our database there, you have the URL there and you can look it up. And this is what a search result might look like. You can type what area you're looking for. Maybe you're going to visit a relative in California or even in New York, and see how often have tsunamis hit our coastlines. Here are the coastlines I'm going to visit. And you could also look at this information through our maps. We have a map service that looks like that, and you can poke around and play with the map and see, okay, where have tsunamis hit? Now, again, this is historical data, and tsunamis, we've only had written history for, a few thousand years in some places and even less time in other places. So we also have things like tsunami deposits that we collect, and other parts of NOAA collect that, and the USGS, or Geological Survey. So tsunamis bring in sand from the deep ocean and they deposit it on land. So that's what we call geologic evidence. So that can help us determine if a tsunami has hit an area thousands of years ago. So while our historical record may be shorter, our geological record may be longer. And we also have tsunami models where we look at likely events that happen. So we understand how earthquakes work, for example, and we say, okay, let's run a tsunami model and based on how this earthquake functions. And let's say it was a bigger one than we've ever experienced. And let's see what would happen, which areas might get impacted. So that's really important, and that's why different cities and states have tsunami inundation maps and evacuation maps that are based on historical data, like we've talked about, but also geologic evidence and modeling. So that takes all of that into account, and that's what determines what areas should be evacuated. So not just the historical data. And this is an example of what you might find for historical data. This is the 2004 tsunami that occurred in the Indian Ocean off of Sumatra, Indonesia. This was one of the largest earthquakes that's been historically recorded, and 250,000 people died from this event. That's a lot of people, and 15 countries were impacted. So the red dot that you see is where the earthquake started, and it ruptured all along Indonesia, which is kind of along this island here. Whoops. And then kind of the energy that you can see is from that orange, it spread out into all these countries and it was observed. Those little orange and blue bars are where observations were recorded that we have. Of course, it impacted more areas than this, but we just couldn't access all these areas to find out what it did. So the bigger the bar, the bigger the wave was in those locations. So it was a really devastating event that impacted the entire Indian Ocean. Other information you can get from this data is what were the biggest and deadliest tsunamis, what were the biggest in height, and then here I just pulled out some of the most deadly tsunamis. And we talked about the 2004 that 250,000 people died over that that we know of. That's been the deadliest in history that we know about. Now, the other 10, as you can see here, is the listing. So what we have is the earthquake magnitude, some were earthquakes, some were generated by volcanoes. And then the run-up height that you see that column there, run-up is what we call the kind of how high the tsunami went inland and how high it was, how big the wave was essentially. So it's in meters there, but that gives you an idea that it doesn't always have to be the biggest tsunami wave that is the deadliest or the most destructive. And then on the right column, you see how many people may have, that we believe have passed away from this tsunami event. Now, one of the more important things to take from this list is, as we talked about the Ring of Fire, all but 3 events on this list are in the Pacific Ocean. So the Pacific Ocean has the most tsunamis and the biggest ones for the most part. So that's something to keep in mind. Again, the Ring of Fire, that whole area there in the Pacific, is the most seismically active and therefore is the most active with tsunamis. And then another thing to take out of this is that our warning systems globally weren't really developed until the 1960s. And the only one that was of these big events that occurred in an area that had a warning system was the 2011 tsunami. The rest of them had no warning system in place when these events occurred. So our warning systems really are working. People are getting the messages and they're being told what to do, and they're being educated and listening to talks like this perhaps, and seeing where their hazardous areas are. And then they get out of those. So the 2011 event, a lot of people unfortunately died, but it would have been a lot worse if we hadn't had these systems and mitigation plans in place. So we're getting better at getting the message out, and hopefully even when you go visit these coastal areas, you'll know when you see a tsunami hazard zone sign or an evacuation route sign, what it might mean and how you might get that message, whether it's from a siren, from a natural warning sign, from a lifeguard, all these different methods that are in place. So that's the end of my talk, and I'm hopeful that we'll have a few questions that I can answer with. I think we only have about 10 minutes or so left, but love to answer anything that might come up. Sarah?
Yeah, and so we did have a question about some of the coursework, which is what Carolyn sent the students beforehand. A student was asking about the size of a wave. It said that the wave was 3.5 feet. So I think what they're saying for the student who asked this question is that this city was not the city that got the big tsunami, but it was further away from the tsunami, but it was still impacted by getting those 3.5 feet waves. So hopefully that answers your question. Another question we got is, how does water surface tension affect tsunamis, or does it?
Yeah, I don't think you're going to have a big effect. Of course, we have a lot of things that affect tsunamis. Like I mentioned, that tsunamis are not generated by the tides, have nothing to do with the tides. But in fact, if a tsunami wave comes in at low tide, you're going to have a lot less impact than at high tide. And we've had a lot of situations where that's the case. So a lot of things, external things, whether it's the shape of your local ocean floor near your coastline, or the shape of the topography kind of as the tsunami comes on land. Let's say it's very steep, or you have a cliff right on your coast. That's going to protect you. So there's a lot of things to take into account, but you're not going to have a huge amount of discrepancy in the behavior and the impact you have. But yes, that's a good point. Like, there's a lot of external little things that do change things, but not enough to have a big impact on the tsunami wave itself. Hopefully that answers the question.
Yeah, and we have a question, and it's from Alex. How far inland do you have to be in a tsunami event? And I'm assuming he means to be safe, to stay safe, or she means.
That's a really good question, and that's the same thing as I had mentioned before. Every area is going to be a little bit different. So you have to look at your tsunami evacuation maps. So when you go to a location, of course, this is what I do, so I always look at the maps when I go to a coastline to see where it is, how far inland they expect the tsunami to go. So those evacuation maps actually take a buffer. So they'll determine how far inland they expect the worst case or most probable scenarios for tsunamis to occur, and then they add a buffer to that to say, okay, in case we're a little bit off, let's add a buffer to that. And so so in some cases that may only be, maybe a half mile inland, or if that. In other cases, it might be a lot longer because it's really low lying. So if you have a low lying area, that tsunami wave can keep moving in, versus if you have an incline, the further you go inland, that you're not going to have the tsunami waves likely travel as far. However, tsunami waves do travel up rivers. They get kind of funneled in. So if you live near a river, areas near that river are going to be much more dangerous because that tsunami wave funnels in and up a river. So you'll have the river all of a sudden looking like it's increasing in height, and you'll see there's a lot of footage online of that. So it really depends on the area. Unfortunately, there's no way to say it's only going to be half a mile or a quarter of a mile. But you just have to look at the maps that have been developed. But again, particularly around rivers, you're going to have it go a lot further inland.
This is kind of a follow-up question to that. So if you don't have time to get inland, should you go into a tall building or should you stay outside? What's safer?
Yeah, that's a really good question. So right now we have a lot of places like in the state of Washington that are developing vertical evacuation structures. So that means a structure that is built to withstand a tsunami wave and the debris impact, that can withstand a tsunami, and people can get to in time and go up based on all the modeling and geologic evidence and historical evidence we have, to go up high enough to be away from the tsunami. So Japan has a lot of these, Indonesia has these, Thailand has these. So there's structures where we know that the tsunami wave will arrive too quickly for everyone to get inland away from the coast. So they've built these structures throughout, and so you go up the structure. And there's actually been a lot of evidence of people just doing anything they can in some cases. Maybe they aren't near a structure like that or don't know where it is. And we've had people just go up buildings and survive, or even climb trees. There's been a lot of evidence of people climbing trees and escaping that tsunami wave and surviving it. So at that point, you have to do anything you can, but hopefully you have enough time to get away from that tsunami wave in the time that's provided. So yes, going vertically, it's not the option we recommend, but in some cases you might only have minutes. So if you see that tsunami wave approaching, there's been a lot of evidence of people surviving them. So it's a really good question. And we have a lot of survivor stories of people climbing trees and hanging out in those trees as long as they can. So that's really good question. Thank you for asking that.
I really want to say thank you to Nic. He's very passionate, as you can see, about this, and he spends his time protecting people, doing all the research into tsunamis. So if we don't have any additional questions out there, then that is our presentation for today. You're welcome to sign off. If you think of any future questions, then you're welcome to write myself or Carolyn, and we can make sure that we talk to Nic for you. But we're getting a lot of thank yous to you, Nic, in the chat. So thank you to everyone for signing on today, and we hope you have a good rest of your day.